Hi everyone, welcome to the 6th devlog of ESHRAQ. In this video I'm going to go through the ontology of ESHRAQ through various diagrams that I've been making in the past few months. Maybe as an intro to warm up, I will give you a very quick overview of the technical updates of ESHRAQ. Some things I've been doing on my times off, just to add some little features. So here we are in the Unreal Editor. I will go very quickly. Maybe in the future I'll have a better record a better video going through them in details. But right now we have a better representation of the sky. So now you can see the sun and moon exactly from the position they're shining. So that means, yeah, this is responsive. The time of day is also now synced with the actual time of day where you are. So you're based on your machine's location, you can set that. That means if right now it's 2 p.m. In Amsterdam, the sun and moon will be exactly the way they are if you are at that time in Amsterdam. So if you come if you log in, or if you open ESHRAQ in the evening, it will be night here. So there's a kind of a synchronicity and a continuation of time between ESHRAQ and real life. But you can, of course, override that. There are weather effects added, implementation of ultra-dynamic weather so you can shortcut to different weather effects such as snow, rain. And there's a new actor called Agent Guy, for lack of a better word. This is a mannequin, but yeah, basically this is Unreal's game animation sample, which is a free project, amazing project. I brought it here. I won't want to spend too much time here, but I'll just give a quick run through. This is the guy, quite realistic animations, as you can see. Yeah, and actually these are new modules. I also made the bike roads, which is the bike roads in Amsterdam. They're all red, asphalts and grass. Kind of a cheap grass, because I don't want to break performance. So you can repeat this a lot without breaking performance. Just to give the vibe of grass. You see these two modules represent well my neighborhood. At least these are the main things I'm excited. I see when I go for a walk. And yeah, there is also a water module where this is also new, so you can go inside it, and yeah, you can repeat it as much as you want to create bodies of water. Cool thing is, I can't show you now, but these are actually 4 modules, 4 cubes. So, but you cannot see the seams, because seamless. Yeah, water is seamless. So yeah, that's about it. Okay, so now back to the main thing I wanted to talk about in this video, and that's the ontology of ESHRAQ. Been working on this aspect of the work always in the background, but mostly in the past, say 5 or 6 months, I was very much involved in kind of solidifying certain ideas and taking the decisions to imagine the ontology of ESHRAQ, because in order to progress on the technical aspect, the ontology is important. Otherwise, you end up changing your system all the time, and it's hard to be consistent. So it's a bit of a foundational work to be so, and also a conceptual and philosophical aspect of the work that is the main thing that drives me to actually start this project. So it's not really just about, you know, the technical aspect and like making something cool in Unreal, but mostly also to think of it as a mean or as an excuse to think deeper in these concepts, computation, immaterialism, illuminationist ideas like Sohrawardi, that is mainly inspired from. So I'm going to go through 3 different pages that I prepared. There's a workflow diagram, mythical cosmology of ESHRAQ, and the actual ontology of ESHRAQ. This might be a little bit dense, but bear with me. I mean, you don't have to, but the reason I'm making these videos is also to not just to share, but also to solidify these ideas as a point in time, kind of like to kind of document the process of the project. Anyways, so we start with the mythical cosmology of ESHRAQ. This is very inspired by illuminationist ontology. That's Sohrawardi's idea of illumination. That means, in a very simple, put it very simply, everything is made of light, and there are different gradation of light. So the world around us, even the material world around us, are a certain manifestation of light. So light itself, for instance, the sunlight is one aspect. Well, it's one gradation of light. So you go more towards the left. It's more immaterial, and the more material it gets, for instance, objects or bodies or physical world around us, tangible world, the darker it gets. So so there's this kind of gradation and hierarchy of light. And then towards the very end, there's this of this spectrum. In Sohrawardi's ontology, there's light of light, which is similar to monotheistic idea of God. But then it also acknowledges certain immaterial entities, such as gods, like many gods, for instance, in Zoroastrianism, or even like Greek gods. In every culture, you have examples of these kind of many gods, like that. It is a continuation, and archangels, demons, and visible lights and celestial lights, and so on. So what I tried to do in this cosmology was to think of ESHRAQ as this computational world where it can be placed. And computation itself is a form of light. It is very it is immaterial in many ways. From how we observe it through screens and pixels, and signals and electricity and all these things, to the core of the processes that are involved into computation. These are things that manifest certain things, and it is hard to think of it as a material thing or object. In the computational world, we have ESHRAQ somewhere in between the tangible world and celestial lies, and then the divine realm that is understood in Sarvadi's ontology. So yeah, we have ESHRAQ here that is kind of as this a computational word that is kind of placed in between this tangible and divine realm, within this spectrum of immaterial all the way to the left and material all the way to the right. So computation can be seen as something in between these two. Yeah, this was just one aspect. I don't go into the details of this cosmology, but just as a starter. The next thing I want to show is the workflow diagram. This workflow diagram is made in order to, so I always had a version of it since I started the project, but I kept changing it and kind of updating it based on how my workflow changed throughout this process. I found it important to have something like this simply because this kind of project has a lot of different aspects that needs a lot of different roles, involvements. And it's important to know which role you are entering or which layer of the project you're entering and with which role. In that sense, you can separate responsibilities and concerns concerning your role. That means it helps you to avoid confusion and getting lost within the process, because there's so many different moving parts, and sometimes it's hard to take certain decisions because you get lost. So it helps you to navigate yourself in the process of the project development. I'm going to actually remove hide the UI so it's more clean. So what you see here is 3 stacks. We start in a conceptual layer, and then there's an ontological layer that the conceptual layer feeds into, and then the ontological layer feeds into the technical layer, and so on. So there's this kind of like a loop here. The technical layer, everything that is results from the technical layer, again, informs the conceptual layer. So I'm going to start and zoom into the conceptual layer. Here we have the sources. So basically, this process is analysis of certain sources. So these are sources that are inspired by life, by anything around us, by the sort of cognitions that we have, our understanding of the world, languages, architecture, fiction, mathematics, ontology, different ontologies, games. So these are concepts from the real world. Then the role that we have in this layer is either as an admin or a contributor. So it's more of an administrative role or a contributor role, that you sort of analyze certain sources, and then you are inspired by some of them. And then you say, okay, I like the idea of wind catchers. So yeah, next thing you do after the analysis, you start to document that idea. So you document the idea of wind catchers, right? This means making notes and certain references to collect things related to that concept. So here we document, for instance, wind catchers. Okay, and then after this step, we go to we enter the ontological layer. So we find that, okay, wind catchers, interesting. Now we start to sample them. Sampling means breaking them into pieces that can be modularized. So this is the process of modularization or fragmentation. So we kind of mince that idea into something that then can be imported into the ontology of ESHRAQ. And I think I explained a little bit about idea of sampling in the early devlog posts. But yeah, this is about demarcation. So you kind of cut so if it's a geometry, for instance, if it's the geometry of the wind catcher, we think about how can we modularize this. So how can we make it something that we can repeat, or make it procedurally, or make a pattern out of it. So then this process is also rather subjective, because everyone samples things differently. So you have to keep that in mind. So once we know, how we want to cut our concept into pieces and into modules, then we enter the ontological mapping process. By the way, the roles that are engaged in this layer are more of a philosophical roles and research roles. So this is more, so you have to think of the deeper ideas behind, this way of cutting something into to a module. Why not the other way? The role of a philosopher can be here to design this whole ontology, this whole ontological framework. The researcher can also feed into that. Can see certain inconsistencies or contradictions, or flag them. So these are the roles that can engage with this aspect of the work. Once we sampled everything, the idea, the concept, like wind catchers, then we need to think of how we can map them into our ontology. That means, what is this item? For instance, can it be a module, or can it be an agent, or can it be a canvas? So here we decide which part of our ontology that concept can be translated into. After this, we do a validation. The validation step is just to make sure that there's no contradiction. So that's, basically just another step to make sure that what we bring into this world, into our ontological world of ESHRAQ, doesn't contradict other concepts. So as an ecosystem, it sort of is compatible. So it's not out of the scope of our ontology. And then we enter the technical layer. In the technical layer, once we know what our concept belongs to in our ontology, the technical layer is basically first entering into a database, and then into the Unreal Engine framework, which is where the simulations happen, where everything comes together. And then there's this iterative process in this mode, which the result of this comes into our outcomes. So I'm going to break this down a bit. First of all, the database right now does not exist. This is just a concept, because this is more like an ideal workflow. The reason behind it is that having a database that is agnostic, that is not dependent on the framework of game engine like Unreal is necessary, because if Unreal stops working, for some reason vanishes from the face of the earth, you still have your database and you can translate it into another platform. So this is one reason that you need a database for a project like this, so you can have an archive that can be understood without the filter or necessity of a framework, a technical framework, or another software. So once we have that database, then that means you archive your stuff. So this could be geometries, like assets, for instance, sounds, could be text, everything that you can put in this archive to make sure you are, it's like your wiki as well. And then that enters the Unreal Engine framework. So then you start to model that idea, then in the first iteration, and then you start testing it. That's at least that's what I do. So when I make something, I start testing it, and then by testing it, you realize you learn new things that you wouldn't have expected. Therefore, that is a iterative process. So then you decide to do some changes in how you archived it. So you archive it differently now based on what you learned from testing. And then again, you model it again. So not from scratch, of course. It's like an iteration of that model to really get to the iteration where that you feel satisfied with that implementation. So this can continue as long as needed. The roles involved here, like a programmer or a designer can enter these frameworks. And then here we come to the outcome, where the work becomes visible, right? So this is basically a different form of outcomes that can come out of this. Here is a list of these examples: an interactive simulation, 3D prints, physical 3D prints, scenography, video, film, prints on paper, publication, and devlog. And the roles in this mode is if you are a player, you play the interactive simulation. If you're a reader, you can read a devlog or a wiki. And if you're a viewer, a spectator, you can view the film or the visual elements. So, these are all mapped in here. So then, these outcomes, like the simulation itself, the videos, the devlog, everything that becomes visible, again, feeds back our conceptual layer, right? So this means what we think about wind catchers before bring it into the system of ESHRAQ is different than what we think of them after, because now we have a new understanding of, we have a bit of a wider understanding of wind catchers, because we saw a new implementation of those ideas within a computational framework of ESHRAQ. So there's this loop, kind of like this snowball effect. So that's about the workflow diagram, and that's this diagram changes over time. Also, it's important to say that, because over time, as you work, you realize, okay, these are steps that are necessary, and these are steps that are not necessary, so just take them out. Okay, now about the last and the most important aspect of the work, which is the actual ontology of ESHRAQ. And I'm going to explain things from left to right, one by one, so you have an idea what it's going to be. So first and foremost is what constitutes user presence in ESHRAQ, that what we call presence in the world of ESHRAQ. Presence means you are surrounded by a model. That means here this is a model, like all these modules put together in certain way. This is a model. So you are inside the model, and we have three elements that are bound together. So there's this binding in between them. Agent, shell, and you. Agent is this kind of mechanical, these are agents. So agent core, agent Wheeler, agent guy, agent FPS, this first person guy. That means these are the bodies that you can take, your shell can take over. So this is very mechanical sort of entity. By itself, it has no kind of, no agency or soul or whatever. And then we have you. You means basically unquantifiable and aspect of you as a player or user. That is your soul. It's important to reference that because then in combination of you, shell, and agent together, they start to make sense. And shell is a kind of like a computational kind of in-between thing that connects you, your soul, into the agent, and therefore into the world of ESHRAQ, into the model. Shell is hard to understand now, but further on I will explain further and you get a better idea of it. But basically all these together, when they're bound together, that means you are alive. And you have agency in the world, so you can change things. You can move things around, you can add certain functions and skills to certain modules. So you have, you can interact with the world, but in a limited way, because you are doing it all through agents, and agents are limited. Just like our own bodies are limited to certain physical aspects. You cannot fly, basically. You need another machine to be able to fly with. But if you're not bound, if it's just your shell and you are a ghost or you are dead. So this is the concept of death in this context. That means you are a spectator, but you have unlimited access. So there's no kind of physical thing that limits your navigation. But you cannot do things in the world. You cannot influence things in the world. Going further to explain those more in detail, we have this ontological landscape. This helps understand what I mean by those three elements. In this diagram, we have you, that is your soul, an ocean, a turbulent soul. So I use the analogy of ocean as something that is deep and doesn't have perceptible boundaries, right? And that's also how I think about the concept of soul. Your soul is something that's hard to define. You cannot really have any concrete definition of a soul. And if anyone does that, that is basically a lie. So in order to visualize it, I thought maybe ocean, a body of water, helps to give a better understanding of it, and also to surrender ourselves to the uncertainty of this concept. So yeah, on the bottom is you. On the top, there's a model of this computational model of ESHRAQ. This virtual desert. So here we use the analogy of desert to better understand what we're dealing with, because it's a good way to think of it. Also going back to the idea of Alam al-Mithal and Nakuja Abad, the desert is a good representation of it, because in a desert everything can exist, but nothing really exists. So it's kind of like, feels like this mirage. So in a way, it feels very virtual and computational, because you can spawn things, but you can also take them away. And then, so as you see here, everything above here is computational, below is more immaterial and like your soul. And the shell is basically this kind of a conductor that places itself between the model and your soul. And then through the shell, it creates this kind of zone of attraction for the soul that it's kind of like creates this kind of gravity that creates this kind of soft contact with the shell. So there's this soft contact here in this zone with the shell. And here we have hard contact, because this is in the computational realm, that is from here above, things are more hard-coded and it's very computational. So you can reference things like in codes. There's no ambiguity. So a shell can interact with the world through agents. And what's inside the shell and what shell does, I'll explain further. Here you can see a visualization of this idea. So an ocean below, a desert above, and the shell is something in between that connects these two together. And if you think of this as more like a temporal diagram, so here we have you after losing contact with the shell, right? So here you are, because of this zone of attraction that was created before, is released now, right? So this body of water, let's say, imagine that, it starts to fall down, which creates a zone of repulsion. And to me, this is a really, this is over time, right? So it creates ripples. And this shape is almost this attracted form of water. This is the negative of it, this void that creates. It's kind of like a memory of what it remembers of this zone that was already in contact with that desert, right? But when it's taken away from it, it creates this void zone that is kind of the inversion of that. And this inversion starts to disperse into the body of water and ripples around. So, yeah, you can think of it in many different ways, but these ripples could also you could think of them as also ways to communicate certain ideas, so that souls can connect to each other through these ripples. But yeah, I don't go into too much details into it. I just thought the temporality of this analogy of water and your own soul and memory was interesting here. Okay. Now to go into more detail of the same ontological landscape, to the inner workings. Here it's like a more detailed version of it. So you can see the inner workings of the shell, what we have in the modules and the models. And so here I think this is a better explanation of shells. It's a set of attributes that can override agents or models' default behavior. Shells are similar to the idea of a character in a game that has a unique set of skills, traits, talents, weaknesses, advantages, etc. Except that a shell has no material manifestation. It's composed of codes, perhaps similar to DNA, you can say. And a shell can have voices and stories embedded to it, which can be revealed through exploration and interaction with the world of ESHRAQ. This process entails is similar to muraqabah. Muraqabah in Sufi, it's a Sufi concept that means vigilant introspection, meditative watchfulness, or conscious self-observation. So it is a spiritual practice where the seeker reflects inwardly to become aware of their own soul, or it's also called nafs, and its relationship with the divine. So it's a form of meditative contemplation, often leading to unveiling, kashf. I mean, these are each of these concepts have lots of complexities, so I won't go into the details of those. But yeah, basically muraqabah, or this kind of like self-observation, is something that can be done through shells when there is this induction happening with the player, right? So here you can see, for instance, inside a shell we have like a collection of visions, or things that like visions that can occur in the world based on certain conditions. The memory, it is like keeps a log of certain activities that you as a user within that shell had, or could be also a kind of a memory that this shell already had from before without being played even. Inner voice and outer voice. Inner voice kind of like what you talk to within yourself, and outer voice how and what you talk to others, other shells and souls around you. Spell inventories, you could have a unique inventory that you have unique spells for you. And certain overrides, that's important, that creates the character or the taste of your character playing in ESHRAQ. So you can have certain overrides for movement attributes, for weather attributes. So for instance, you can have a shell that always overrides the weather and is always rainy, for instance. So this kind of effects can be done here in the shell. So it's kind of like the taste of your, it defines the taste of your experience as well. So shell interfaces with agents. And through agents, you can do things in the world. You can manipulate modules, helpers, canvas, atmospheres, etc. But below, here we have mean, this is kind of funny, but I thought of visualization of it because when you have this kind of soul ocean below, there is this idea of so we have this like kind of like pins because here is computational and here is not. So this soul water and turbulence, this is always ups and downs. So this defines your presence within this simulation, right? And inputs. So, for instance, if I decide to press the S key to go backwards, this is an intentional thing that me and my soul have, and I connect that through my body, and I press that S button, and somehow then there is this connection, right? That becomes concrete. So I send that signal into the computer, into the software, right? And then the software handles that signal. But the source of that signal is coming from my soul, right? But then sometimes when you play a video game, for instance, you are not in the flow, right? You're just in the menus and like, so maybe your connection to these pins are much less or much more fuzzy, like more sparse. But when you're in the gameplay and like you're in this very intense multiplayer action game, and you're completely in the flow zone and you're completely transported, this turbulence and this connection becomes much more dense, and lots of more signals are sent. So that's why you probably feel present within this simulation, because your soul can send more signals and receive more from this computational substance. So yeah, hopefully that explains a bit of this soft contact I meant. Let's go next. I go through this quickly because these are more also work in progress, by the way. Another thing was the relationship diagram. This helps a lot with to know what the scope of things in terms of their relationship, meaning that especially it's useful when you think of it from the perspective of object-oriented programming, like C++, that is the core of Unreal Engine as well. There's a concept of inheritance. That means things we have classes, but classes can inherit from each other. So there's this hierarchy when you're programming your objects. So it's important to have certain side of a kind of a relationship diagram if you are working on a game or a software that is mostly object-oriented, like ESHRAQ itself. So here we have, well, first of all, I'm going to clarify that it's not object-oriented ontology. It's not at all that. It's object-oriented programming. So that's just to be put that aside. These are two very different things. Anyways, so we have shells on the top, so they can relate to mod. So these are basically all the elements in the ontology of ESHRAQ, all the components. So if you have something in ESHRAQ, it belongs to either of one of these, right? It's not, so you know the scope of your components. So it's not something, if there's something not defined yet, we either have to define a new category here, a class here, or we have to find a way to make it part of one of these. So we have shells, we have agents, two kind of agents: field agents and machine agents. Machine agents are resembling NPCs, or more like state machines, things in video games. That it's an agent that is interactive, that interacts with the user, but it has only computational form of agency. That means there is no sort of intelligence, deeper intelligence than what the computation allows it to do. But it doesn't mean it's useless. It's important. Like we don't have it yet in ESHRAQ, but I see some at some point having them, because they just create so much interesting depth to interaction and presence in the world. So they have field agents. That's basically all these fellows are field agents. Model, we have models basically consist of these elements: canvas, assemblies, and modules. So modules are, as I explained before, are these assemblies could be thought of. So this could be thought of one assembly, or this could be thought of one assembly. Assemblies are combination of modules. Helpers, these are helpers. These are sort of things that help us interacting with the world, but they're not part of they're not a module, right? Atmosphere is the sky and weather and everything else around it. So yeah, these are these can all be referenced by spells. And spells, as you also remember from other episodes, are the sort of functions that you can here we have a spell inventory, sort of functions that you can apply to and send to objects around you. So these are basically things that we already know. But one thing that's cool about the relationship diagram, when I wrote it, right, when I visualized it, it started to show me kind of connections where I didn't expect. For instance, I thought, okay, if spells can be applied to modules, but what if they could be applied to assemblies and canvas? So this really expanded what I thought about the spells as a feature, because you could have a spell. You could have a spell that can affect. You could have a spell card that if you reveal it, it will change the weather. So right now, all the spells are affecting just the modules, individual modules. But you could have a spell that could only affect an assembly. Let's say this playground. And if you apply it to something else, it would basically don't work. So that is a good potential for spells. And then here we have, for each of these elements, I try to create inner mechanisms. These two diagrams, these are helping a lot with technical implementation of ESHRAQ when it comes to Unreal Engine, especially, and coding. So it is, of course, informed by more ontological and philosophical thinkings, but also here it shows its potential more in technical aspect. So for instance, when we talk about a module, right, what is inside the module, right? As a F module, It can have a spell container that can contain spells. So that means we can define that we already defined a certain kind of array that holds these spells. An attribute container. So attribute container means that every module can have attributes. For instance, this module can have health, can have armor, can have whatever you could think of, right? And then that variable will be saved inside the module. And they all have geometry, material, physics, and movement. These are different components. These components are made out of codes, by the way, of course. So, no need to explain. We have spells, and spells are pieces of codes that can be thrown into things in order to get certain results. So they should have a target, a reference target, the attributes that are within that spell. So you can have a spell that increases your the speed of your car by 20, right? Or you can have a spell that increases your speed of your car by 300, right? That's the attributes of your spells. This is where the function itself lies, where the code is, and the codex. That means the codex is a human-readable version of the code. This is more like a code poetry kind of thing. So that's where you write a description of the code in a poetic way, so you know how this spell, what this spell is going to do. Agents, again, this is more technical, and these are stuff that are cramped into agents. So they all have animations, skeletal mesh, and accessories or whatever. So I guess, yeah, that was, let me see if that was it. Yeah, that was it. That was so far the ontology of ESHRAQ. This was pretty dense, and I think hopefully with these kind of ideas now I have a good kind of perspective of how to go forward, because right now, for instance, the shelf, the idea of the shell that was very prominent in the ontology, right now it doesn't have an implementation in ESHRAQ. So I have to start thinking about how to implement these ontologies into ESHRAQ. Some of them are already still are here, like agents, modules, and canvas and everything, but shell and other kind of complex ideas that and connections that were in the ontology will hopefully present itself in the coming months and years. So yeah, that was about this one. Thank you for watching. Goodbye.